So welcome back for the afternoon session. And our first speaker this afternoon, a man I've known for a very, very long time, is one of our foremost observers of comets. We were just chatting earlier. He's been observing comets for over 50 years. He's one of our leading comet astrometrists. That's an interesting word to say. Of all the astrometrists in the world, he's the amateur with the third highest total, over 25,000 astrometric positions. Not as important as that, he's the secretary of the Comet section and its deputy director. So here to talk about Comet anti-tails, and we've already heard a little bit about those, please welcome Denis Buczynski.
Well, thank you very much, and it's good to be here amongst friends and many people in the audience I know, some new faces, which is always great to see, members of the ASE, who I must say are one of the very best astronomical societies I've ever joined, and I'm proud to say that the work they do for their members is quite terrific. So thank you, ASE. You may have spotted the deliberate mistake, which was pointed out to me by Alan Pickup, wherever he is, that it's October the 5th on there. Well, I promise you that I'm not going to be speaking past midnight tonight. I'm going to try and finish in my allotted time. And you will also, for the Scots who are here, and there's a lot of English here, and Northern Englanders, which is good, you will have noticed that I'm gradually losing my Lancashire accent and becoming a Scottish speaker. Is that obvious? Is that obvious? Anyway, what I want to talk to you today about is comet anti-tails, which are really a unique feature of comets, obviously. But I'm not an expert on this thing, and if there's any orbital dynamic experts here, then please pull me up after my talk at the back and tell me where I've made a blooper. Right, comet anti-tails. This is going to be really just a sort of conglomeration of what we know about them, when they were first observed, and bring up to date as to what the latest observations of them are. So comet anti-tails are visual, photographic and digital contemporary observations to the comet section. Right, so first of all, let's say what comet tail evolving theories are. There's a lot of information in these slides, and I don't expect you to read it all, but I'll just go through some of the main parts of it. Over the time, theories of how comet tails were formed and appeared in relation to the head and the coma were explained by astronomers such as Olbers and Bessel in the 1800s, and then Bredekin in the 1900s, and finally Finson and Probyn in their seminal work in the 1950s. And if anybody wants a reference to the seminal work, you'll find it on that slide. Well, the case of anti-tails. An anti-tail is an apparent spike extending from the coma towards the sun, and therefore in the opposite direction to the gas and dust tails. The anti-tail consists of larger dust particles left behind by the comet. These dust particles are less affected by the sun's radiation pressure and tend to remain roughly in the comet's orbital plane and eventually form a disk along the comet's orbit due to the ejection speed of comet particles from the comet's surface. As the Earth passes through the comet's orbital plane, the disk is seen side-on and appears as a characteristic spike. The other side of the disk can sometimes be seen, although it tends to be lost in the dust tail, which is trailing behind the comet. The anti-tail is therefore normally visible for only a brief period when the Earth passes through the comet's orbital plane. So there are no mysteries and no anomalous features in comet tails. However, their appearances have been sometimes surprising and many times spectacular. So, when were these first comet anti-tails first seen and recorded? Well, looking back through the literature, certainly looking back through cometography, which lists all the known comets, this was the first comet that I could find that had a recorded anti-tail, a Great Comet of 1823. And you can see these two guys here, who discovered the comet, Biela and Pons, who were both great comet observers. And you can see here what it says in the text there. The sunward spike was only seen between January the 21st and January the 31st, only a short period of time. However, the antitail appeared as bright as the main dust tail and was 7 degrees long. This short period of visibility and the non-alignment of the tails is crucial in understanding the phenomena due to perspective and the relative motions of the comet and Earth around the Sun. So that lays the tail for us. Now, before 1823, I can't find any references to comet antitails in the limited amount of literature that I've searched. There may be other instances, but this was the first one that I could find. Well, next up, after 1823, we went more than a century before there was any mention of antitails. And surprise, surprise, a comet discovered by Aaron and Rowland. It became as bright as magnitude 1.6 and displayed an antitail 15 degrees long and a main tail 30 degrees long. Of course, this was a famous comet, Aaron Rowland. And this was really the first time that an antitail was visible and photographicable. The antitail was visible from 57 April 23 to May the 2nd, so it was only a 9-day observing window to see and photograph this anomalous tail. And this is how the press and the public were introduced to antitails, by saying, this is an anomalous feature, it's physics defying. This is what made it interesting for the press and the public. And you can see the two astronomers there who discovered it, Aaron and Rowland, and you can see an image there showing a wonderful picture of the antitail. The antitail on Comet Rowland was a cometary feature that had probably never been photographed before, and so the press and public were eager to see pictures of this and find out more about this unusual comet tail. Fortunately, the press in this country were able to turn to a wonderful man and his comet imaging machine, Dr. Reggie Waterfield, who was the prime comet observer in this country at that time. He had been observing comets since 1917. His first comet was one that John mentioned before, Comet Devlin, and he was finished his observing career observing Halley for the second time in 1986. He started his observing career with Comet Halley in 1910. And so he was one of those lucky people who saw it twice. He wasn't at his best in 1986, I must say that, but he did actually get to use his equipment, and we imaged the comet for him. So anyway, the press, they decided that they would hang out at his observatory and wait for him to take these plates of this comet with this physics-defying tail. And some of the press camped out at Waterfield's Ascot Observatory waiting for the plates to be developed and dried, and then whisking them away for publishing the next day's newspaper. And you can see some of the prints there that were in the newspaper at the time showing this tail. Such was the public interest that the RAS mounted a whole exhibition of Waterfield's Aaron Rowland pictures for the public to come and see in Burlington House. So that was quite an episode in his life, and it really made his name, not that he desired any fame, he was famous enough in the BA as he was. Here's a cover illustration of the Comet Bibles, cometography, which shows a picture here of Aaron Rowland stood next to the 200-inch, sat next to the 200-inch with that press photographer there rushing to take the plates back for him to print somewhere in America. So it's lived its own legend as Aaron Rowland as being the first photographable comet that had an antitail. Well, there may have been wonder amongst the public about this physics-defying cometary tail, but cometary scientists quickly developed the explanation. And in a paper in Nature, Fred Whipple wrote, "No extraordinary physical theory appears necessary to account for the growth of the sunward tail. The sunward tail must almost certainly have been resulted from the concentration of cometary debris over an area of the orbital plane. Seen at moderate angles to the plane, the material possessed too low a surface brightness to be seen easily, but edge on, it presented a concentrated line of considerable intensity. Those were Fred Whipple's words. He was the Comet man in the 50s. He was the man they all turned to for explanations of these things. Here's a simulation of that comet passing by the sun there. And if you can see, just as it gets to the top there, you can see the antitail just appear there, just as it's above the sun. And that's a marvellous simulation by Nicholas Lefferdu, I think you call him. And he's got many of these simulations on his website of all famous comets showing the development of tails. And they're well worth a look at on his website. I think they're marvellous, marvellous things, these. Well, next up was that infamous flop, Comet Cahootek. We've heard plenty about this. 1975, and if ever a comet needed to perform, it was this one. It's like Manchester United today, they need to perform. The hype and speculation over its appearance was staggering. Everybody knew about Comet Cahootek. It was going to be, as John said, -9, according to some experts. Comet of the century. Not quite. And you can see here that on these two Central Bureau for Astronomical Telegrams, there are observations made by BAA members. You've got Waterfield mentioned here, his observations of Comet Cahootek. You can see in observations here of George Alcock. You can see here observations by John Bortle, the famous American comet observer. So although this comet was predicted to be very bright, it never became so, at least for the earthbound observers. There was, however, interesting reports of a bright antitail. You'll see from the IAU circuits that the BA observers Waterfield and Alcock reported this feature, as well as well-known comet observer John Bortle. Comet Cahootek's antitail was observed by the astronauts on the Space Lab in 1973. And you can see pictures and drawings, a pastel on black cardboard rendering of Comet Cahootek made by the astronaut Edward Gibson, based on his observations made during the Skylab 3 mission. He took the opportunity to observe the comet visually through the different windows in the Skylab during the 84-day mission, supplementing electronographic images taken by various Skylab telescopes. So this was the first antitail that had been seen by anybody outside the Earth, or off the Earth. Professional papers were published about this time as astronomers explained the nature of these cometary features. And you can see here papers by Whipple, you can see papers by Sekanina, and that I think the German chap that I can't pronounce, but there were plenty of professional papers produced to explain what these antitails were, to dispel any notion that they were something that were physics-defying. Still in the era of photography, in 1980s, the next comet to show an antitail was the great comet Hale-Bopp. And the image you can see there is an ESO La Silla observatory images with a 1 meter Schmidt telescope. And the image shows a dust tail in the anti-solar direction, extending over a distance of more than 4 degrees to the edge of the field. Since the photographs were made near the time that the Earth was crossing the orbital's plane, they also show another feature there, which is called a neckline structure. And you can see this structure coming back here. Interestingly, there was also a narrow sunward spike. That's the antitail there. That may be followed for at least half a degree in the other direction. In the 1980s were a period of transition for comet observers, moving from photography to digital imaging. And this increased photon gathering power and superior resolution allowed us to record cometary features that had only been observed visually in very bright comets. And you can see this comparison here, and we were seeing some pictures earlier today that Nick had shown, of Kagaya's comet here with these shells, and Nick's image in here, not of Kagaya, but of Hale-Bopp, showing similar structures in the inner coma. And again, Nick's observation here of the tail features are the same as Comet de Chezeaux there in 1743. I think it was Klinkenberg's comet it was called originally. I don't know why it ended up being called de Chezaux's comet, but it was it had a very bright six-rayed tail, and Nick has recorded similar features there with that comet. So that's the wonderment of really of digital imaging. Next one up, Comet Bradfield in 2004. That displayed an antitail during the orbit plane passage. And you can see Bill Bradfield there with his homemade telescope, which he discovered many comets. 13 comets Bradfield discovered from the southern hemisphere, and every single one of them has only got his name attached to it. Nobody else was a joint discoverer, and that's a record that Bradfield holds to today. So that had a short antitail, and you can see in that pictures there, you can just about make it out there. The same comet, the neckline structure was also seen, and you can see that in this image here. You can see the antitail at the front there, and that line there running through the comet's dust tail, which effectively is the same feature as the antitail. Visual observer Martin McKenna in Ireland observed the antitail of Comet Bradfield in 2004. And what was really good about this, and this is a page from his logbook, is that when he went to observe this comet, he didn't know that antitail was there. He just drew what he saw. And I've spoken to Jonathan about this earlier. You know, it's really a very special skill to be able to just draw what you see and not be influenced by anything you've seen or heard before. So Martin is to be greatly commended for that. Comet Lulin in 2007, and we saw one of Martin's pictures earlier of Comet Lulin, also displayed an antitail. And you can see there that negative image and also the colour image by Joseph Brimacombe. And again, you can see Martin McKenna's drawings of that antitail, again, visually. The current era of more sensitive and larger CCG chips allowed us to record comet tails more often and in stunning colour as well. Memorable was 2011 Pan-STARRS, 2011 L4. And this image, mosaic image by Peter Lawrence, shows a 16-degree long antitail. These are quite terrific features, very, very long. And some wide field images there of 2011 L4, and you can see there just how striking and how long that antitail has become on that particular day. I think that image at the bottom is by Nick James again. So some software to visualize comet tail orientations, which you'll find on the web. There's the Comet Toolbox. You can also look at comet tail orientations in Stellarium, and there's another one there by the Jet Propulsion Laboratory, which you can log on to and put in the parameters, and it'll give you the comet tail lengths and the orientations. So those are very useful if you want to be doing what Martin wanted to do with his remote images and find out just exactly which way the tail's going to be lying, and in fact if there is any anti-tail that's likely to be visible. Oops, go back one. 2022 saw the discovery of 2022 E3 ZTF, which again we saw a picture of Martin's, which displayed a prominent antitail. And Miguel Claro imaged the comet from the dark sky in Portugal, showing 3 types of dust of tail. And you can see here that the iron tail is blue, and the dust tail and the antitail are both reddish. So you can see that the iron tail is made up of gas, and the antitail and the dust tail are made of the same dusty material. Again, more again there from 2022 E3, and Dan Bartlett's image from June Lake in in California. And also, again, Martin McKenna's drawing at the telescope of the same feature. So, you know, as we spoke before, drawing comets is still very important, and I think that Martin is to be greatly commended for his observations. Comet 12 Brooks, who we saw plenty of images earlier, was a stunning spectacle with a bright anti-tail. And you can see some lovely pictures there of the comet. More images of Comet Brooks' tails. In colour imaging, fantastic now for comets. It's incredible. Oh, Comet 223A3 to Shinshan had a spectacular anti-tail. It's bright enough to be seen visually from a dark sky, and Nick's image there on the left-hand side is from the visitor centre on La Palma, and another very detailed pictures there from Naveen Ravinder. And this showed a really very bright anti-tail, one that could be seen visually, and those are few and far between. Most of the anti-tails we see are either imaged or photographed and not seen visually. And so Nick's description of him going to La Palma to see this anti-tail was quite something. And here's some more of 2023 A3, and again Martin McKenna there drawing it visually again, and Chris Scher is observation from Arizona. Well, we're coming towards the end now. What's the next comet that's going to show an anti-tail? Well, do we know? What about this one? Comet 3I, this new interstellar comet. Surely not. It's not going to have an anti-tail, but not a conventional anti-tail perhaps, but it's described here as such by Hubble Space Telescope's comet scientists, showing a tail. But this tail is orientated in the sunward direction. Now, it's not considered to be a conventional tail, because basically what I think they're saying is that the solar pressure which is being put on the comet at this distance isn't enough to sweep this dust backwards at that point. But since then, we've seen other observations, this is from the Gemini Observatory, showing that the comet has now developed a more conventional tail, pointing away from the sun, but they believe that the anti-tail is still there, but hidden by the rest of the coma. So that sort of brought us up to date, really. And just to finish off, I'd like to say we've gone from a situation where a cometary feature was rather a mysterious one, which created a lot of interest and a lot of speculation, as these things do, and one where we can confidently predict now when an anti-tail will be seen on any comet at any apparition, such as the development in orbit dynamics, software to predict where these things are, how they can be seen, and that we're able to access that information. So thanks for listening, and keep your eye open for that next comet anti-tail.
Thank you very much, Denis. Any questions for Denis? Yes, Jeremy.
That was excellent. Thank you, Denis. You mentioned there'd been no observations before around 1820 of
Yeah.
I just wonder, might it be possible to use this software that you've been describing to roll that back for some known comets in time and look at observations from
I suppose
1600s or whatever?
I suppose that is possible. It's just which comets to pick, isn't it?
Yeah,
There's
well,
so many of them.
But if you selected some of the brighter ones that are well observed, and it may be that they're clues in the descriptions of the time that have not been yet interpreted
I
as being anti-tail.
I understand what you're saying. There probably has been comets that have had anti-tails, but we haven't recognised them as such.
Yeah.
But because we know exactly what the causes these things now, is the cake worth the candle? Is it worth that work going to find, well, this comet had an anti-tail, so what? It's just part of the dust tail. We're just seeing it at an angle that makes us allow us to see it.
Yeah.
It doesn't really make any difference to the physics of the comet. So is it worth that work? They're an interesting phenomena, but
I think from a historical perspective,
Possibly.
it'd be really quite interesting.
I mean,
and quite remarkable if people had observed these things and we hadn't realised.
And what would be a testament, really, if they did find observations of them from visual observers, because that's when we're talking about, prior to 1850, 1860, there was no photography, so it was all visual stuff before then. So if there were observations of antitels, it will just show how good an observer they were, because they certainly wouldn't have been as bright maybe as McKenna's drawings of them have been.
Any questions for Dennis? No?
No, good.
Okay.
Beat me up at the back if I've made any bloopers. Anyway, thanks for listening, and it's been great